Hi, in this video we are going to see about a Python IEEE project which is entitled as Smartphone Addiction Prediction using Machine Learning, which is an enhancement of IEEE base paper titled Machine Learning Prognosis for Smartphone Dependency, which is an IEEE 2024 conference paper. So before seeing the execution of the project, let me speak about this project. So today everyone is using smartphone, from the kids to the elder people. So every task or everything is connected with the smartphone, for studying or for traveling or for shopping. Everything is today connected with the smartphone. So usage of smartphone is increasing day by day. But the problem comes here when it is used over and it makes the addiction. So when it is addicted, it has various kinds of drawbacks to the psychologically to the human being. It gives various problems like anxiety, depression, stress, etc. So in this base paper, so authors have identified the smartphone addiction using the machine learning. So in this base paper, the authors have used 3 machine learning algorithms. So that is decision tree, logistic regression and random forest. So here you can see they have used the data set for the training, the system and testing purpose, the model building, and result and prediction is done. So here they have used 3 models: logistic regression, decision tree, and the random forest. So in the base paper, the authors have achieved the accuracy for random forest as 77.9%, decision tree classifier as 81%, logistic regression around 74.5%. Kindly note that we're not going to do the same model as mentioned in the base paper. So now we are going to improve, we are going to enhance the thing from the base paper. So let us see our proposed system now. So we are also going to develop 3 different models. So the one is stacking classifier model, second one is CatBoost classifier, third one is ExtraTrees classifier. So our proposed system contains 3 models of this. So now let us see about the accuracy. So in the first model, that is stacking classifier model, we have achieved accuracy train score of 100% and test score of 94%. The second model, using CatBoost classifier, we have achieved train score of 99.84% and test score of 96.12%. And in the final model, that is ExtraTrees classifier, we have achieved train score of 99.84% and test score of 100%. So from the 3 models, ExtraTrees classifier has performed well, but from the compared to the base paper, the results, you can see all the 3 models that we have done is very good than compared to the existing system, that is the base paper concept. So now let us see about the project abstract document. So here you can see the smartphone addiction prediction using machine learning is our proposed title, and IEEE base paper title is machine learning prognosis for smartphone dependency. This is the IEEE base paper abstract. So coming to our proposed abstract, so we are given the small introduction about the smartphone addiction, which is growing every day, where excessive mobile phone use impacts the mental health, productivity, and the social interaction. For addressing this issue, we are proposing this smartphone addiction prediction using machine learning. So this project is developed using Python for backend coding. The front-end part contains HTML, CSS, and JavaScript, and web framework we have used is Flask. So everything is being described in this part of the abstract. Then coming to the data set part. So here the data set part contains 501 records with 21 attributes. So these data set is being trained in the system. So before going to the next part, I'll show you the data set part now. So the data set part is available in the model, inside the model code. So this is the data set that we have used to train the system, which contains the features like timestamp, full name, gender, do you use your phone to click pictures of class notes, do you buy books, access books from your mobile, does your mobile phone battery last a day, when your phone's battery dies out, do you run for the charger, do you worry about losing your cell phone, do you take your phone to the bathroom, do you use your phone in any social gatherings, that is parties, do you often check your phone without any notification, do you check your phone just before going to sleep, just away after waking up, do you keep your phone right next to you while sleeping, do you check emails, missed call, text during class time, do you find yourself relying on your phone when things get awkward, are you on your phone while watching TV or eating food, do you have a panic attack if you leave your phone elsewhere, you don't mind responding to messages or checking your phone while on date, for how long do you use your phone for playing games, can you live a day without phone, whether you are addicted to the phone. So these are all the features that is in the data set. So as mentioned, it contains 501 data set records. So this is the complete data set that we are going to train up our system model. Now coming to the abstract part, the next part contains about the models that we are going to use, that is stacking classifier, CatBoost classifier, and the ExtraTrees classifier. So those accuracies whichever I mentioned is being described detailedly in this part, and finally we have summarized the abstract part. So this is about the proposed abstract. Coming to the existing system, so we are taking the base paper as the existing system. So in the base paper they have used random forest classifier, decision tree classifier, and logistic regression. So those details have been mentioned, and what are all the accuracy that they have achieved in the existing system is being described in the existing part. So coming to the next part, that is disadvantage of the existing system. So the main disadvantage is the accuracy part, so that is being described here. Another significant drawbacks also available for each model of the logistic regression and decision tree classifier and random forest. Those things have been technically detailedly explained in this disadvantages of the existing system. And coming to the proposed system, so as we know that we are going to develop the smartphone addiction prediction using machine learning with the our model stacking classifier, CatBoost classifier, and the ExtraTree classifier. So the main model details are being described in this proposed system part, and the technical part details have been described here. And coming to the advantages of proposed system, so the main advantage, key advantage is the improved prediction of the accuracy, enhanced generalization, handling complex non-linear relationship, efficiency in handling categorical data, reduced model complexity, faster model training and prediction, robust web integration, user-friendly interface. So those details are being described and summarized in this advantage of the proposed system. And coming to the system architecture, so the input that we are going to give is the smartphone behavior data set. So based on the data set, the pre-processing and feature selection is made, and then it is being trained with the stacking classifier model, CatBoost classifier, ExtraTrees classifier, and the predicted result will, whether you are addicted to phone or not, will be predicted result. And finally we'll show the performance analysis and the graph part. So this is the hardware requirements of the project, minimum requirement, and the software requirement. So this project can be executed in Windows 10 or 11. The coding language that we have used is Python 3.12.0. The web framework we have used is Flask. The front-end part contain HTML, CSS, and JavaScript. So this is the reference of the IEEE base paper. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python the library is installed in your system. Now inside the source code location, we have this smartphone addiction folder. Inside that we have this app.pfl and other files. So here in the address bar, let me type cmd and click enter. So the command prompt window open with the exact location of it. So now here type python space app.py and click enter and kindly wait for a few minutes. So now you can see this URL. Just copy this URL. Go to any of your browser and go into Google Chrome, paste it and click enter. So now you can see the home screen, a welcome screen of the project with the project title. So first click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see this login success message and click OK. So now it will be navigated to the upload part where you need to upload the data set. So just click this choose file option. So inside the source code location, we'll be having this upload.csv file. So just select this and then click upload button. So now it will be navigated to the preview part where you can preview the data set that we have uploaded. So I already shown you the data set contains this ID, stamp, name, all the details. So everything is been updated here. So which contains around 500 dataset records. So here we have loaded only few dataset records to show you the preview part. So now let me click this, click to train or test button and kindly wait for a few minutes. So now you can see the training finish message, click OK. So now it will be navigated to the important part, that is the prediction part. So here in the final case you can see that you have kept an option of model. So here you can see the model, ExtraTree model, stacking model and the CatBoost model. We can select whichever the model you wanted and you can predict the result of it. So now let me show you few cases with each of the model. So first, for the first case I will just select the gender as male. So here you can see the options. You can just select whatever the option you wanted. I'll just give the option on the test cases given. So now you can see the question that do you use your phone to click pictures of the class note? So the answer is yes. Do you buy books, access book from your mobile? Yes. And when your phone's battery dies out, do you run for the charger? Yes. Do you worry about losing your cell phone? Yes. Do you take your phone to bathroom? Yes. Do you use your phone in social gathering parties? Yes. Do you often check your phone without notification? Yes. Do you check your phone just before going to sleep? Yes. Do you keep your phone right next to you while sleeping? Yes. Do you find yourself relying on your phone when things get awkward? Yes. Or you on your phone while watching TV or eating food? Yes. Do you check emails, missed call, text during class time? Yes. Do you have panic attack when you leave your phone elsewhere? Yes. You don't mind responding to messages or checking your phone while on date? Yes. And how long do you use your phone for playing games? So this is less than 2 hours. Can you live a day without phone? Yes. So for the first case I have maximum given all the things as yes. So now I'll select the model as ExtraTree model and then click this predict button. So now you can see the model that I have selected is ExtraTree and the result is whether you are addicted to phone is yes. So this case is addicted to the phone. Smartphone addiction is there for this case. So if you wanted to export this result, just click this download PDF option. So let me save it as 1 for this case. The first case I'll just saved as in one.pdf. so here you can see what all the details that I have entered, and here you can see the model that we have used and whether you are addicted to the phone or not. The result case is yes. So this has been exported in a PDF format. So now let me go to the prediction menu again to check with the other case. I'll just, instead of telling the each questions, I'll just enter the values and show you what are things that I have done. So for the second case, I have given the thing gender as male, and the maximum all things are yes. So the cases which I have no is, do you buy books, access books on your phone? No. And this case, do you take your phone to bathroom? No. And this case, or using your phone while watching TV or eating food? No. And do you don't mind responding to messages? No. And this has less than 2 hours, and the model that we have selected is the second model, stacking model. So everything, this is the result, this is the input values I have given. Let me show you the predicted result for this case. So now you can see the model that is selected is updated as stacking, and you can see the predicted result is no. So this case does not have any kind of smartphone addiction. So similarly, you can just export the value in the PDF format for the future reference. So now I have saved as 2.pdf, and you can see the model that we have used and the result case for this case that whatever I have entered. So now let me go to the prediction menu again, and finally I'll show you the other case. So let me say you the details quickly. So gender female, and for the no cases is like when your phone battery dies out, do you run for the charger? No. Do you worry about losing your phone? No. Do you use your phone in social gathering? No. And for your phone while watching TV or eating food? No. Do you find yourself relying on your phone when things get awkward? No. You don't mind responding to messages? No. Can you live a day without phone? No. And how long you're using? Greater than 2 hours. And does your phone's battery die last a day? No. So now here I selected the final model as CatBoost model, and let me check the predicted result for this case after clicking the predict button. So here you can see the model used, and you can see the predicted result is yes, it is a smartphone addiction case. So you're seeing the details, and similarly I'll just export the result to 3.pdf. so here you can see the details of the things that we have entered and the predicted result value. So in this way you can check with the other cases by entering the test or train value from the dataset part, and you can check the predicted result for it. And now let me move to the next part, that is the performance analysis. So in the performance analysis we'll be seeing about the stacking model training part with the precision recall in F1 score, and stacking model testing case with precision recall in F1 score. So here you can see the train model confusion, stacking train model confusion matrix, stacking test model confusion matrix. Next, coming to the second model, that is CatBoost training model with the precision recall and F1 score, and CatBoost test model with the precision recall and F1 score. And this is the CatBoost train confusion matrix. This is CatBoost model text confusion matrix. And then comes the ExtraTree testing model, training models of precision recall and F1 score, and ExtraTrees model test with precision recall F1 score. And then the train confusion matrix of the ExtraTree model, and test confusion matrix of the ExtraTree model. And finally comparing the all three models with the stacking, CatBoost and ExtraTrees with their accuracies. So the performance analysis part contains the precision recall F1 of the three model, stacking, CatBoost and the ExtraTree with the precision recall F1 score, and then it contains the confusion matrix of all the three models with the train and test model cases. So this is being summarized in the performance analysis part. And finally the chart part. So kindly note that this is a static chart because we have not used any database in the project. So these are static charts only. So the first chart shows the accuracy score of the each model: stacking classifier with 94%, CatBoost classifier with 96.12%, and ExtraTree classifier with 100%. So those being compared in the first chart. And second chart contains the distribution of the phone dependency score with the phone dependency score and the number of students on it. And then comes the distribution of phone dependency score based on gender, male and female. And then comes the daily phone usage habits, addicted with non-addicted part. And next chart is the time spent on phone for game versus addiction thing. And then the phone usage in social gathering, addicted versus non-addicted. And finally the static visualization of the dataset part, which contains the 60% of no addiction data and 40% of the addiction data in the dataset part that we are trained up with. So this is all about the chart part. And now let me log out. So before concluding, let us see about the frequently asked question about this project. So the question is, what is the main objective of your project? So surely this question will be asked in your IEEE. So the main objective is to predict the smartphone addiction of student or the user using the machine learning based on their analyzing their user behavior and the smartphone usage pattern. This must be your answer. So I'm just going to give some few points only. Based on that we elaborate and you can answer it. So the next question is, why did you choose smartphone addiction as the focus of your project? Because this is a growing concern in the digital world. So this is impacting many students' mental health and the productivity and the personal relationship, etc. So because of that, to overcome, and if we are finding that earlier, we can just overcome those issues and we can have a good environment. And third one is, what data set did you use in this project? So here we are going to use the behavior data set of the smartphone user, which contains 501 data sets and the 21 attributes. So this data set is referred from Kaggle. So how did you pre-process the data set? So there are various pre-processing steps. For example, handling missing values, converting categorical attributes into numerical form using encoding techniques, normalizing the data where necessary to ensure the consistent scaling, splitting the data set into training and testing to evaluate model performance. So what machine learning model did you implement in your project? So we have implemented 3 model: stacking classifier, CatBoost, and the ExtraTree. What performance metrics did you use to evaluate your model? So the performance metric that we have used is the test and the train accuracy. Other than that, we have also used metrics like precision, recall, F1, and confusion matrix, whichever I have shown you in the analysis path. And the next question is, why did you use a stacking classifier model? So we have used the stacking classifier model because it combines prediction of multiple base classifiers to form a meta classifier. So this approach often improves model performance by reducing the bias and variance of individual model. So the stacking classifier helps capture diverse aspects of the data by leveraging the strengths of different algorithms. So how does the CatBoost classifier differ from other gradient boosting algorithm? So the CatBoost is specifically designed to handle categorical data efficiently without extensive pre-processing like one-hot encoding. So it builds decision tree with minimal parameter tuning and offers faster training times compared to the traditional gradient boosting method. So this makes excellent choice for data set with many categorical feature as it directly processes them. So the next question, what was the most challenging aspect of your project? So the main challenging aspect was tuning the machine learning model to achieve high accuracy without overfitting, especially when we are using smaller data set that is around 501 records. So this is the main challenge. So what role does ExtraTree classifier play in your project? So ExtraTree classifier is an ensemble learning method that builds multiple decision tree based on random splits on the training data. So its key role is to reduce variance and improve the robustness of the prediction. So in our project, ExtraTree classifier was particularly effective, achieving 100% test accuracy, making it one of the most reliable model that we have used. So these are all the frequently asked questions. So you can just make use of it and you can prepare for the Viva Voice. So this is all about the project smartphone addiction prediction using machine learning or machine learning prognosis for smartphone dependency. And thank you for watching.